Okay, let's think about moments that are sitting at an angle. And just to review, moment is the tendency of a force to cause rotation, and the way you figure it out is force times distance. Now, as we said earlier, distance is measured from the pivot point perpendicular to the line of action. So no matter what angle your wrench handle is sitting at, it's from the force, from the line of action, that you measure your distance. Here's the same wrench with the same length of handle and the same 25-pound force pushing down on it. The one on the left has the handle straight out. And if moment is force times distance, we have a 25-pound force and a 15-inch length distance, and so the moment on that wrench is 375 inch-pounds, and it's actually negative 375 inch-pounds. Do you know why? It's because this force is trying to turn clockwise, and clockwise moment is negative moment. Now, let's say you're trying to loosen some nut under the hood of a car, and you may have experienced this before, or maybe under your sink, some plumbing under your sink. And when the wrench is straight out, it's easier to tighten, but if you're in some cramped position where the thing can only go up at an angle, you get less moment, less tendency to cause rotation, and let's see why. There's the distance from the pivot point perpendicular to the line of action. If moment is force times distance, we still have the 25-pound force, but now the distance is only 12 inches because the thing is up at an angle. And so we have only a negative 300 inch-pound moment when the thing is at an angle. And just a reminder, we said that when a thing is rotating clockwise, that's a negative moment, and when a thing is rotating counterclockwise, that is a positive moment, consistent with what we see in AutoCAD angles. So here's our next problem in our quiz. This looks really daunting, and if you wanted to figure this out with your calculator, it might take a while. I know it would me. I wouldn't do that. I'd draw it in CAD. So here's a pipe wrench, 17 inches from the center of the pipe out to where you're pushing on the thing. And you're pushing on the thing with a 39-pound force. And he says, calculate the moment through the center of the pipe caused by that force. Well, what the heck? We have all these angle things. The secret is the distance is from the pivot point perpendicular to the line of action. So here's the pivot point, the middle of the pipe. Here's the line of action, that arrow. Here's the distance from the pivot point perpendicular to the line of action. And if I were you trying to solve this pipe problem, I would draw this in CAD. You have enough information to do that. That's what I would do. So here's an illustration of how no matter what angle your wrench handle or anything else is sitting, it's always the distance is from the pivot point perpendicular to the line of action. And see how that distance stays the same? It's perpendicular to that arrow no matter what angle we tip it at. That's still the distance. It's the perpendicular distance. Let's go look at our wrench now. Here's our wrench. And if you were trying to figure this out, maybe you were at work trying to figure this out, you wouldn't go to the bother of doing all this wrench drawing. I just did that for your benefit. But really, you just make a simple triangle and you draw this thing at whatever angle they tell you, and then you'd measure how long is that line. You could use an an aligned dimension, or our friend the distance command. Now let's go back to our wheelbarrow, which is the next problem. So we're trying to figure out what is happening with this wheelbarrow. And he tells us there's 100 pounds of dirt, let's say, in the wheelbarrow. It's pushing down here. And then there's you lifting up on the handle here. And the handle is sitting at a 20-degree angle, he says. And along that handle, it's 20 inches from the axle of the wheel up to where the dirt is acting. And then it's another 28 inches from there to where you're pulling up. That's the setup. Now the question is, he's asking you two things. Find the moment of the 100-pound weight around the center of the wheel, so that's this thing, and then find out how big a force you need in order to resist that weight. And as I often do, I have put the answers that you should come up with down here in the bottom of the slide, just so you can check your work. So here's the first half of the problem. Find the moment caused by that 100-pound weight. And here's the second half of the problem. Find the force P required to resist this moment. And when he says resist this moment, what he means is how much force does it take to lift this thing? So let's look at our drawing again. Here is our, let me zoom down a little. Oops, sorry, don't do that. I have pasted our problem in here, and then I zoom down a little bit more, and then I drew a simplified wheelbarrow with some triangles in here. All right, so here's our whole problem. Let's look at part 1. In part 1, he says, what is the moment caused by that 100 pounds of dirt? So we're looking at 100 pounds of dirt acting through the bin of the wheelbarrow, and it's rotating around that axle. Now, keep in mind that the distance, when you say moment equals force times distance, the distance is from the pivot point perpendicular to the line of action. And here's your line of action going straight up and down. So that's nice that he tells you it's 20 inches along the sloping handle, but is that the distance you need? No, it's not. You need this distance from the pivot point perpendicular to that arrow. So using what you know about trig, if you have a triangle here with a 20-degree angle, and you know that the hypotenuse is 20 inches, you're wanting to find this side along the bottom, aren't you? And what is that? Is it opposite or adjacent? It is next to that 20-degree angle, so that's the adjacent side. So think about which trig function can you use if you have a hypotenuse and an angle and you're looking for an adjacent. And your quiz walks you through that, of course. Then part 2, now we're trying to figure out, okay, if we figured out how big a moment this dirt is causing, how can we get this lifting up force to cause the same moment, just in the opposite direction? This dirt was rotating clockwise, so it's a negative moment. This lifting up force is rotating counterclockwise, so it's a positive moment. I think I drew an arrow down here. Oh, yay, I did. So here is from the pivot point, the center of the wheel, perpendicular to the line of action. So you could, if you want, rotate that thing from the pivot point perpendicular to the line of action. What we want to know is, what is that distance? Well, we have, what do we have? Still have a 20-degree angle, and now we know we can figure out that hypotenuse. It's 20 inches plus 28 inches must be what? 48 inches must be that hypotenuse of that triangle. So you've got a 20-degree angle and a 48-inch hypotenuse. What is the adjacent side? And once you know that, now you've got a force times distance over here and a force times distance over here. And your quiz is going to step you through figuring out how big a force do you need in order to have the same moment over here that you had over here. But be sure to holler if you have questions.